Chris, and I'll be trying to solve. A boat is pulled toward a pier by means of a tag cable if the boat is 20 feet below the level of the pier and the cable is pulled at a rate of 36 feet per minute. How fast is the boat moving when it's 48 feet from the base of the pier? So let's try to draw what it's asking us. So we have a boat right there, and it's being pulled towards by cable. I would assume it would be like this. If the boat is 20 feet below, so if I right here, I don't know how a pier looks like, so I'll assume it's a lighthouse. This is the pier, and it's 20 feet above the boat, and I am 48 feet from the base of the pier, and I'm being pulled in at 36 feet per minute. So this is our little module over here, and we're trying to find how fast is the boat moving. So we have to know what is our constants. So our constant that will always remain the same is 20 feet. Our change will be 36 feet per minute. We have to see how fast is the boat moving. So let's call this chunk right here x. So dx over dt is equal to what? Okay. From here, I see that this is a triangle. And with triangles, you can either find the area, but this question isn't asking the area, it's asking how fast something is moving. So with this identity, we have to use the Pythagorean theory, which is a squared plus b squared is equal to y squared, or c squared, but I'll choose y this time. So we have this, and we have to see how fast something is moving with respect of time. So how can we know, or how can we try to solve this? Well, if I have a constant and I have a derivative or respect to time, I am going to have to do something with my identity, in which I have to take the derivative with respect of time of both sides. But since I have a constant that was always moving, that was always staying the same, because height can never change if you don't cut it, we can actually just let's put this as b, because we're trying to find the base. A squared can be our constant, so 20 squared plus b squared is equal to the derivative with respect to time of y squared. Perfect. And the derivative of any constant will be 0, so 0 plus b squared with the derivative of respect to t will be 2b of db of dt is equal to, same thing here, 2y dy of dt. Trying to solve for db, we have to we have to do algebra to basically try to find it. So from here, I could take out 2 divided, this is being multiplied, that crosses out, so it would be b over db dt is equal to y dy over dt. b is being multiplied to db over dt, so the opposite multiplies division. So db over dt is equal to y over b of dy over dt. And this is how we're going to find the speed of the boat when it is 48 feet from the base of the pier. So from here, I have dy over dt, because here, this is my rate of change right here. This is dy over dt is equal to this. However, I don't know what y is. Y is something we need to know. So how can we find y? To find y, we can actually just go back to our identity and try to solve it. So, oh sorry, that was the wrong pin. So it will be y squared is equal to, so here we can actually use all of our constants, so it will be 20 squared plus b, our base, will be 48 squared. The opposite, or trying to get y by itself, is the square root of both sides, so y is equal to the square root of 20 squared plus 48 squared. Y is equal to, I have to get a calculator, 20 times 20 is 400, so the square root of 400 plus 48 times 48, 2,304. Adding that together would be 2,704. And if I take the square root of that would be, take this 52. 52. So y is equal to 52. Alright? So now we have all of our pieces. We know what to find the speed of the boat by using this little formula right here. We know our y and our b and the respect of that. So now we can plug everything back in. So db over dt is equal to y is 52 over, what is our b? Our b can be found as 48. 48. All this being multiplied by 36. Okay, so dB over dt is equal to 52 divided by 48 times that by 36 will be 39. Okay, but we're being pulled inwards. We're not by this module. Our speed of the boat is getting pulled by the pier, so we're not going forward, we're actually going backwards. So we're not necessarily, going away, but we're actually going back to the pier at negative dB over dt equals to negative 39 feet per, so by second or by minute? I think it's by a minute. Okay, and if you wonder how I got the negative, since if we're talking about our speed should be negative here, because we're pulling our thing inside. Boom. So that is our answer for the question.